And here we are for the last panel of this conversation about trustworthy digital ecosystem. The last but very important discussion is about how these technologies are helping us in making decisions, and if it is an ethical, a legal, a technological challenge. We have to talk about that Fosca Giannotti, who is professor of computer science at Scuola Normale Superiore and researcher at the Information Science and Technology Institute of the National Research Council in Pisa. And with her, Virginia Dignum, professor in social and ethical AI at Umeå universitet in Sweden. So Fosca, who has probably some problems in the camera, is already showing a presentation about AI decision making. Fosca.
Okay, thanks. So I apologize, but there are some technical issues that I have not been able to solve. So first of all, thanks for organizing this very interesting workshop. And what we are going to discuss, me and Virginia Dignum, is perfectly in line with the previous panels. So we will try to give I will try to give the perspective from the point of view of what kind of technology are we designing in order to support all so ethics by design. In some sense, producing the technology that can operationalize the injection of values in the AI technology. So one important part is when AI systems are interacting with humans for supporting them in their decision making, and that's in particular in high stakes scenario. That's very important. It's very important that we have this technology because can strongly improve the quality of the decision, providing new knowledge and providing appropriate form of knowledge. But on the other side, we want that the technology does not fail. So we want to improve trust of that technology. We want that this technology is capable of expanding the human autonomy, not going towards a society where the people can demand completely to the algorithms. So this project, which is a project which works synergetically with so big data, and actually part of the algorithms are made open or available, shared with so big data. So it's focus on the explainable AI, the technology just from the point of view of supporting decision making. So the model that we have in mind is that the kind of decision making that we have in mind is the one like we call this metaphor of Dr. House model, where the Dr. House is a very intelligent agent which interacts with other very intelligent agents that are proposing to him new hypotheses. They challenge him with new knowledge, and also they contrast him, the hypothesis that he poses. So there is a debate, but at the very end, the final decision, it's the responsibility of the final decision is for Dr. House. So this model implies that we have also to rethink some of the technology, the data, the AI technology which is behind. So there are two different big families of explainable machine learning, the technology in the area of explainable machine learning. And there are those two families. One, it's what is called explanation by design. That means that we focus on machine learning models and technology, which is natively explainable, I would say. So, and the other family is what is called the black box explanation. So there are black boxes, there are machine learning models which are intrinsically opaque, but we can try to accompany them with some explanation technology. So this is pictorially the representation of those two different scenarios. From one side, explainable by design methods. So you try to provide the boxes are transparent, not black. And in the other way, in the what we call the post-hoc explanation, you stay with the black box, which are opaque, but we keep such system with an explanators. At the very end, we are providing a new form of machine learning, which is capable of producing natively or post-hoc some form of explanations, which may be of different kind. There is a variety of different form of explanation that those two pieces of software, or natively or post-hoc, can produce. They may be in the form of feature relevance. In some sense, we say, okay, for this particular decision that we propose to you humans, so the motivation of this decision is given by this particular relevance of features, or can be in a sort of rules, logic rules. This is true because of this, because this form, because your education is greater, it's a very high grade of education. So it can be in the form of sort of logic rules, or can be in the form of prototypes, so examples, similar things. You are similar to that, or Contra Examples, counterfactual reasoning that activate a different kind of reasoning, the contrastative reasoning. So if you want to obtain a different outcome, a different prediction, or a different recommendation, those are the things that you have to change, sort of stimulating a different cognitive process. So just to give you an example, in images, there are, what we call feature relevance on images means to show which portion of the images are particularly relevant, or as a prototype, so counterexample, show a similar image, which is something which is a synthetic image, which is similar, and explain why that prediction, or other in the text you highlight as a feature relevance, highlight some portion of the text, some keywords which have been particularly relevant. Okay, so now as a counterfactual, you see this example. You show what you can be changed. You should change to obtain a different decision. You don't have obtained the loan, but if you change something, you might have different outcome. It's a sort of activated sort of what-if analysis. Okay, and that's it. So those are exemplars. So you can generate exemplars and counterexamples. So it looks like this, or it is different from this. So this is the kind of reasoning which you want to activate. So behind more the algorithm, now those are the basic brick of creating this form of reasoning, or symbolic reasoning, where we augment the explanation with some domain-dependent knowledge, or we create this form of causal reasoning. Where in those cases where you are capable to say, this is because of that, or something more sophisticated, human in the loop. In some sense, you try to activate an explanation as a sort of conversation, human-machine conversation, where your black box that can be again transparent or what else, but it's that box is capable of interacting, answering providing different form of explanations. The user can ask further information. So you can say, you can explain the rules, you can explain also what are the similar instances after questions, or exemplars which are not similar. Then you can start to reduce the number of features. So starting this sort of feedback loop between the algorithm and the human decision. Of course, for doing this, you need to have make it to understand better which are the models of human decision making. So that means it's not anymore enough the knowledge of computer scientists. You have to get advantage of the other disciplines like cognitive psychology, where there are theories which are capable of modeling this the process of a human decision making. So this two-way of reasoning between the machine activated this sort of conversation. This is just to say you that how can we create trust? You create trust because the system give the humans the options to interact, to provide further explanations, even sometimes being capable of saying, okay, on this portion of information, I'm very, 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 very secure. So you don't want to be boring in some sense. You try to gain this trust, trying to solve the easy problem and involve the humans in the difficult part. So this is essentially what is now trying to do the technology in this area. So now I stop here. I'm sorry because I don't have my cam, so I can stay listening the next presentation and then participate without the cam. You see my nice picture. It's one of the best pictures that I have.
Thank you for giving me the opportunity, even if it will be very short. My main message, and I think that's what I would like to make clear now, is that when we talk about decision making, we need to really look at context. And we have to look at context in many different ways. And some of the issues that I also from the previous presentations and the previous panels, I'm getting a bit concerned about the way that we are conceptualizing AI and artificial intelligence at the level of the European Union and the AI Act and other types of regulations, but also in the way that we are conceptualizing this type of technology in terms of the capacity, the possibilities for decision making, for impact in human society and humanity. This conceptualization is problematic, in my opinion, in two different ways. It is problematic because we tend to conceptualize an AI system as an entity, an agent. There were several of the previous speakers talk about the agent, which seems to give the idea that we can identify what is the AI system, what is not the AI system, and we can create some kind of a border around the AI system. This way of seeing it is increasingly different from what AI systems are in reality, and also live outside of the conceptualization, the fact that the technology, the AI technology, does not exist in a vacuum, but it's integral and inseparable part of human and societal ecosystem. So we really need to start conceptualizing AI as an ecosystem of components, some of them technical, some of them institutional, some of them human. And that is when we talk about ethics, when we talk about responsibility, when we talk about regulation, we really need to address this very diffuse thing, which is not an entity with a beginning and a end, with this is the AI, this is not AI. It is also problematic in the way that there is an idea that an AI system as an user. So it assumes our conceptualizations, and that is clearly reflected in the way the AI Act and other of these acts around AI are defined. There is this person or persons which are in one way or another interacting with the system or affected by its results. So in this way, we are not really taking potentially enough attention to the more systemic effects and the more systemic interactions of AI with the environment, with the society and the natural environment in general. And the last issue I would like to make in this conceptualization is the datification of society that we are seeing, and that is increasingly pushed forward by all these acts that, especially at European level, are being developed. So AI seems to be intrinsically related to data, and also society is increasingly seen as being is inseparable and identified by the data that we have. So we people, we societies, we environment are much more than data, and we are in the danger, I feel, of leading to the idea that the things that we can datify are the issues that count. Things that we cannot datify are issues that are becoming increasingly less relevant. And I think that this is a concerning development in the way that we are dealing with society and with human impact in general. So we are more than our data. It's much more, and it is not a metric for success, the things that we are datifying, but we really need to look at other ways to look at what is relevant in society. And one final issue is I think it's related to the first one, to the idea of the conceptualization of AI. It is also the conceptualization of the by design. Jeroen van Hove was describing the by design as being the way to go forward. Often we see the idea of the by design, ethics by design, or responsibility by design, explanation by design, and so on, as a property or a functionality that has to be developed into the systems, into the behavior and the results of the system. I think that we need to extend this idea of by design not only to the systems, to the software, the programs, the algorithms that we are developing, but it has to be integrated in the processes and the governance structures that are around the systems that are being developed. So it's not just about the by designing, integrating ethics, responsibility, and privacy and other concerns into the design of the systems, but also taking that perspective in the governance structures and the processes, the development processes that are around the systems that are being developed. And unfortunately, I do need to move to my next keynote, which starts in 4 minutes from now. I'm sorry.
Thank you very much, Virginia Dignum. Your speech was very important to us. Final questions for Fosca Giannotti, and then we let everybody go. Yeah, well, one more thing about the designing and creation of this kind of approach that you mentioned could be given to the data aspect of the systems that you are describing. How do we make a better understanding of what data can tell us? I mean, biases can be understood before they make damages, and what can we do to prevent biases in the wrong way?
So let me first say that I agree with many things that Virginia said, in particular the fact that it cannot be only data. It's the context, and we need to describe it. It has to be done by design, and we are we cannot consider only the system, the AI system, as a standalone. But it is a person and machine, but the person and machine then are inserted in a socio-technical system. So there may be each other, when they interact each other, they change each other. So when a decision is proposed, the mind of the decisors is changing. So that's why we are still a lot of path to do. So understanding this the decision-making process, how it works, and this kind of interactions, what are really the effect of this kind of interactions, both at the level of human machine and also the impact on the entire socio-technical system. So to answer your questions, so the data, the quality of data, it is important. We need to have element. So because our our system learn from data, learn from the experience, and we are developing methods which continuously learn and they want to learn about also the evolution of the situation and so new data, when new data coming and describing new situations. So it is important to be really to have tools for understanding the quality, to the biasing as much as possible, but keeping the pipeline, the design pipeline, completely under control. So some of the things are, you have to do a design, I would say, a well done design, but you have to continuously control the what is changing in the world with respect to the data, the training set that you have, and have a continuous update of your system. So that's another phase of the questions of the continuously evolving reality. And if you're putting your system in such a technical system, it's a sort of co-evolution of the reality together with the AI system, which has to be considered.
Yes, Fosca, this is the right thing. I know. My name is The Bias, so I'm very interested in this kind of debate, but also I'm super interested in the idea that we should improve the design of the process, of the governance of the way we produce this kind of solutions, as Virginia Dignum mentioned and you underlined. So this idea of creating a different governance of the process is at the same time clearly the way to make our technologies better and at the same time a very risky process, because it makes it slows down the creation of new technologies in a context in which competition doesn't seem very much worried about this, but they just are worried about conquering markets and occupying sections of the digital environment. So for Europe, this is surely the way to be, but it is also a very challenging way to be. At least we can be proud of this. I hope this panel and this whole presentation was interesting for our audience. For me, it was, and I hope that we continue talking about this arguments with So Big Data, Reimagine Europe, and all the participants that we had the honor of hosting here. Thank you all, and to the next time.
Thanks very much for organizing this.